I'd like to look at a problem in which we're going to graph a function, identifying just everything. And you can say, what do you mean by everything? I mean everything. So I'm going to choose a function. Let's start with a polynomial. That's the easiest possible function. And then we'll branch off from there. So let's say I'm choosing 49 on page 307. In other words, is in 4.3. So this is g of t, which is 3t to the fourth minus 8t to the third and plus 12. And the question is, let me put the book away because it's in the way all the time. It's so heavy. So this is the requirement. Graph it, showing everything. Okay. I rarely ask my students to use a particular method, but this time I'm going to kindly ask you to use this method and try to understand it. Okay. We're going to, from the beginning, create a table. And every time we find something, we determine something. So this is the first derivative. We come back to the table and put it in. In the middle, we have g of t. And the last one, the last row, is the second derivative. We find something, we put in the table. We find something else, we come back and put in a table. On and on till we finish. So in our analysis, we have to start with the function. And what can we find about the function? X and y intercepts, limits at infinity, if the function has vertical asymptotes, if it has horizontal asymptotes. That's about it. Okay, so domain, of course. It's a polynomial function. I know you're going to say, well, it's everything. There is no problem. It doesn't have a square root. It doesn't have natural log. It doesn't have a trig function. It doesn't have a denominator. So it's a polynomial function defined everywhere. Okay. Immediately, I will find the limits at infinity. Okay. So then I have limit from the function 3t to the fourth minus 8t to the third and plus 12 as t approaches infinity. And the same thing when t approaches negative infinity. Can anyone identify these two limits? I'm plugging my computer. Okay.
But the infinity one be infinity and the negative infinity will be negative infinity.
Exactly. However, remember, we always look at the highest power. And the highest power is even. So that was the idea. Correct. But since the highest power is even, no matter what I plug in, what will the result be?
It's going to be infinity.
Yes. See how important my props are. So t to the third is too small. If you plug in 5, everything counts. But if we're talking about infinity or negative infinity, these two do not count. They're too small to mention. This one will dictate. So then, this is infinity and this is infinity. And of course, because these are infinities, we're not even discussing horizontal asymptotes anyway. Good. The next thing that I need about the function is to plug in 0. Can anyone give us the y-intercept?
Is it 12?
That's it. Perfect. So now let's define the x-intercepts. For the x-intercepts, we know that we have 3t to the fourth minus 8t cubed and plus 12 equals 0. We have a feature that I would like us to use. Where are you guys? I lost you again. Here you are. And let's use it. It's the app. If you don't have it, I can show you a different way of determining the zeros or x-intercepts. So x-intercepts are also called zeros. Zeros. Sorry, zeros of f of x. I really like that z, but it makes no sense. Okay, the zeros of f of x. Same thing. Either the x-intercepts or the zeros of f of x. Okay, so let's go back. If you do not have the app, tell me, and I'll show you a different way of determining the zeros. Okay, so go to the app and use number 9, and it's a polynomial. It's degree 4, so choose 4, please. And next. So are you telling me that it can give? Oh, interesting. Okay. Okay, so the first coefficient, they have to be in descending order. The first coefficient is 3. The second coefficient is -8. The third coefficient is missing. The fourth coefficient is missing. And the last coefficient is 12. And now solve. Aha. So these two are imaginary. And look at that. So it's not that that's silly. See, this is exactly what what TI-86 shows. Good. That's interesting. Awesome. Okay, so the equation has 2 solutions, or the function has 2 x-intercepts, or the function has 2 zeros. 2.4 is 1x, and the other x is 1.5. Okay. So
How did you get to that again?
Yes.
How did you get to there?
Yes. Let me show again. So there is a PPS here. You may not have not all calculators have this, though. Do you have it?
Yes.
Okay, so you go to APPS and then you choose 9 at the bottom, and then you put polynomial degree 4, and then you
Mine only goes to 6.
Yeah, mine does too, but instead of going to, I believe it's 4 that takes you to the polynomial root finder.
So you don't have the polynomial root finder?
What's here is poly root finder. Is that what you're talking about?
Yep. So the order is basically the degree, so you have to put 4. So this is the simulator, so I'm not really sure if it's exactly the same. I have to look at my calculator. And then in my case, I have to click on graph. And then I enter the coefficients. So the coefficient of x to the 4th is this, of x to the 3rd is this, of x squared that does not exist, so it's 0, of x that does not exist, so it's 0, and then 12. Are we okay with that so far? Yes? No? Can I move on? Continue?
Yes.
Anyone else needs help with anything? Okay, so in my table, these are my findings. So I have that 1.5, 0, and 2.4, 0. Now, I would like you to use, everybody's different, the entire page. And sometimes, as you see, you can wait for a second and then plan, after you get the solutions. Here, I really want to show what I'm trying to do, but I may have to copy the table again in case the first and the second derivative have numbers in here, critical numbers, who knows. So I may have to redo my table just to make it as clear as possible for you. Okay, so if I end up writing numbers in between and it's difficult to read, then I will copy my table. I will repeat, I will, rewrite it. There is no need otherwise. Okay, I cannot erase because I'm using I can, but it's going to take longer. Okay, so this is done. There is nothing else I can find from the function itself. This is done. X and Y intercepts for this polynomial and the limits. Now I can move on to the first derivative. And when I find anything, I go back to the table and put it in, whatever I find. So then g prime of t is 12t to the third minus 24t. Okay, so g prime of t equals 0 because there is no point in trying to find undefined because there is none. G prime is defined everywhere. It's a polynomial function. So I have 12t to the third minus 24t equals 0. I will divide immediately by 12 and factor out t, right? So I have t to the third minus 2t equals 0 squared. So 12t to the third minus 24t squared, okay? So then I will factor out t squared and I have t minus 2 equals 0. Yes, I do have 3 solutions, but 2 of them are 0 and the other one is 2. Any questions so far? Any questions? So I found, say it again.
I was going to say, does the 12 count as the 0? Or is that just completely out of the place now? Oh, there's a divide symbol right there.
However, let's say I have this problem. 2t minus 4 equals 0. And I write this. Can I ever say 2 equals 0 and t minus 2 equals 0? Let's say I did not divide by 2. I only factored out 2. So I have 2t minus 2. Can I ever write this?
No.
No.
That's a constant.
Okay? We are solving the equation. So that's the reason why I always divide. Because I do see this in paper, tests and quizzes and so on and so forth. So I don't want to see it. So that's why I divide from the very beginning, so I don't see that situation. I know it's tempting, right? But we can't write something like this because 12 is not 0. I cannot divide by t or t squared, okay? So you can say, okay, you divide by 12 because it's a common factor. Why didn't you divide by t squared? That will be a terrible mistake because then I will omit this solution. It will go away. I can only divide by something that is not 0, like 12. Because 12 is not 0, I can divide by it. But I cannot divide by t because t can be 0. So I go back now and I put 0 and 2, and I'm getting into trouble already. So bear with me. I'm going to write it as is and then copy it nicely and neatly for everyone to see. So we have 2 critical numbers, 0 and 2. 0, and see, I have to squeeze 2 in here. And then I also have to determine this number. This is mandatory. Once I determine critical numbers, 0, 12, 2, comma, blah, blah, blah. So I have to plug in the function. And this is here g of 2. So let's find g of 2. So the function is 3, x to the 4th, and then minus 8, x to the 3rd, and plus 12. And now I plug in 2. And I got -4. Okay, fine. Okay, at this point, I need to study the sign of the derivative. I will plug in a number to the left of 0. I will plug in a number like 1 here, and I will plug in a number like 10 here. In the derivative, we do not study the sign of the function. There is never a need to study the sign of this function. We are only studying the sign of the derivative and the second derivative, first and second. Okay, so here is my g prime. So my g prime is 12t squared t minus 2. I refuse to put any number in this quantity. Why?
Because it's squared, so it will always be positive.
Exactly. Thank you, Katie. Perfect. Because it's always positive. I don't even look at it. So to the left of 2, remember, if you imagine the graph of this, you have to imagine this, a linear function with a positive slope. So it has to be before 2 is negative and after 2 is positive. Or just plug in numbers. Before 2 is negative. After 2, it must be positive. Okay, at this point, I'm checking whether these two rows work well together. I exhausted G prime. G prime is done. Critical numbers increasing, decreasing, max, min. There is nothing else I can learn from it. So now let's see what we have here. From infinity to 12, what does the function do?
Decrease.
Very good. Is that supported by the sign of the first derivative?
Yeah.
Perfect. From 12 to 0, what does the function do?
Also decrease.
Is that supported by the sign of the first derivative?
Yeah.
From 0 to -4, what does the function do? Is that supported by the sign of the first derivative? Now, what does the function do from -4 to 0?
Increase.
Good. Is that supported by the sign of the first derivative?
Yeah.
And from 0 to infinity, the same thing. So the two rows work well together. The numbers that I obtained, yes?
Did we just never mind.
So the numbers I obtained are in sync with the sign of the derivative that says the function must be decreasing from -infinity to 2 and must be increasing from 2 to infinity. What type of point is 2, comma, -4?
Absolute minimum.
In this case, but at least the relative minimum. Awesome.